So the big news is IBC Alpha, the IBC Alpha branch got merged into master.
Hooray!
Yes, after many months. That's super exciting. There are still a few issues remaining on the GOC readiness. Ooh, 1 second to get the door.
Yeah. There's a few issues remaining on Game of Zones readiness. Probably the nastiest of which is going to be the prefix, the different address prefix stuff that we need to sort out about the relayer and the. I don't know that there's any issues on the chain. It seems like there are no issues on the chain, which actually, and possibly some of the things that we've figured out in the fixed removing the source address field on the destination on the packet should reduce the number of places where there are contexts in which the relayer is simultaneously dealing with two different address prefixes. But yeah.
Sorry, package delivery in Germany is very picky. They require that you get it at the door, even in the days of coronavirus. Trying not to,
Did you wash your hands?
Get too close. Yes, that's why it took longer. I washed my hands. Anyway, I was saying that there's still a few issues left on the Game of Zones readiness milestone, pretty minor ones. We need to finish up the prefix store PR, implement simple acknowledgements for dealing with the case of failed transfers and refunding tokens on the source chain, prevent channels from being closed, and we need to fix a bug we discovered while end-to-end testing with the relayer in the way capabilities are currently implemented in the SDK.
This is the Gaia thing, the Genesis thing.
No, this is issue 5965. We probably also need to fix that, but I think this is a separate problem.
Yeah, cool.
Once those are addressed, I believe we should be able to cut Game of Zones RC1 or perhaps a point release on the SDK. But there's also some other SDK work in flight. So whichever is first. We also went through, at the Tuesday call this week, all of the issues on IBC spec 1.0.0, which is milestone 5. And, oh, oops, sorry, it's milestone 5 on the spec repo. It's probably a different number on the SDK repo. IBC 1.0 is milestone 21 on the SDK repo. And all of those should be up to date. Hey, Fede. Your video is frozen. So that's pretty much the update from me. Things are going well. Also, Informal has started looking over the handshake in detail, and it's great to have their eyes on it. They're finding some abstractions maybe that could be clearer, and maybe even a few bugs we need to fix. So I'll be working on those on the spec repo. They're already tracked in issues.
It seems like the Game of Zones readiness of the SDK is probably a little bit ahead of the relayer, though I can potentially block some time to help out there. Jack.
Yeah, it is also possible for interchain for IG to have someone help with the relayer.
Okay.
If you guys would appreciate that. As soon as we get the SDK release cut.
Let's get the SDK out, and then let's cut a Game of Zones release of the SDK, and then I can kind of circle up with Jack.
That sounds good.
I think Jack's relayer office hours are at the same time as this right now, which is why he's not here. Because calendar, sorry.
I thought they were an hour before, but maybe.
I think what happened is daylight savings time causes this to shift.
Classic.
And now they have collided. I was very confused. Yeah. I was like, why do I have two? I didn't notice until this, like, now. Yeah, now I have a 1 hour gap in my schedule. And then
and there is no good workaround for that.
Yeah.
Right? There's no time you can pin it to that will make that not be a problem.
Yep.
Mm-mm. Well, the EU is getting rid of DST in 2021, so
which way did they settle? Always on, always off?
Off, I think.
Cool. Solar noon, man. I think we'll get there, but I bet it's going to be another 5 years.
Probably. Any other agenda items? That's pretty much the end of mine.
I wanted to talk a bit about protobuf migration.
Mm-hmm. Go ahead.
Yeah, so we merged yesterday IBC alpha to master, and so I'm now working on rebasing all the protobuf PRs to that branch as well. The only thing is that there's a bunch of changes from the, so just to give some context, the proto migration branch from IBC module uses the some types that come from Tendermint, especially for ICS7. So in order to use protobuf for IBC, we also had to use protobuf for those Tendermint type, and the branch that uses that on Tendermint that uses protobuf is pretty much breaking everything. So I had to update those as well. To the branch is called proto breakage, and it changes basically everything from ABCI headers to Tendermint proto headers and other related changes. So my question here is, should we once that's finished builds and all tests passing, should we merge that PR to master, considering that it'll break pretty much every Tendermint time? Or should we keep it as a feature branch kind of thing?
You mean it will break Tendermint in the sense of existing SDK users will be unable to switch to the new version without migrating data stores or something?
Every Tendermint type will have to be migrated. I already have a PR that migrates everything because that was the requirement for the product changes on ICS07. So if I understand correctly, the plan was the plan for releases was to release 039 on the SDK with the proto changes, and then 040 would be IBC. The thing is that I'm not sure if 39 will have these proto breaking branch from Tendermint or not. If it will, then I guess we should merge. I guess we could merge this proto breaking stuff from Tendermint to master, and then and include the IBC module with proto as well. But if it doesn't include the if it won't include these breaking changes from Tendermint, then we could release.
I see. We can't finish the IBC proto migration until we import the upstream changes from Tendermint, you're saying, which will be changed throughout the SDK. Right. Well, seeing as we have to upgrade to proto anyways, if we can get the other proto stuff in 039, that seems fine to me to merge it to master, but maybe it would be a good idea to ask Baz. I mean, we're going to break things anyway, right?
Baz and Marco. Yeah.
Yeah. So best break things all at once as long as there's an upgrade script. That would be my guess.
Yeah, I'll check with Bess and Marco if the next SDK release will contain these changes, and we can decide from there. But just wanted to make you guys aware that for the migration from IBC, it's gonna pretty much break up.
Yep, thanks. Brian, how is Agoric's IBC integration coming? Is there anything from our end that you're blocked on?
Not yet. We're kind of working out what the abstractions are that want to live inside our code. Michael has a plan for kind of channel API and trying to figure out how to put a sort of OCAP API in front of it. And I think that's going in the right direction, but we're trying to clear up some bugs for our hackathon right now. So I think today we're not getting a lot of time on that, but tomorrow probably some more.
Cool.
So going well so far.
Sounds good. Well, let me know if you are blocked on anything.
Yep, will do. Thank you.
Cool.
I did hear that some of it was moving from passing byte arrays around to passing around JSON blobs. I think Michael said that was...
No, there was just a mistake in the decoder in ICS 20.
Okay.
Which was expecting a binary blob, but in fact, the packet had been encoded as JSON.
Okay.
It's up to the module, right? Because now it's a byte array to the SDK and to the core IBC modules. So it's up to the end module, which owns the channel, how it wants to encode and decode. But it has to be consistent.
Okay, but the channel, to use old terminology, it's now 8-bit clean. There's what's like email servers couldn't send arbitrary bytes. There was a time when you could only send ASCII through them, or there was something in the middle that was expecting it to be.
There is no such restriction. Arbitrary bytes.
Now you can send arbitrary bytes through the IBC pathway.
Yes, constrained only by the type of the Go byte string slice.
Got it.
Whatever.
Got
it. I
it.
think
Sounds
it's
good.
just bytes. Yeah.
Yeah. Cool. Thank you.
And in fact, there's no particular reason to encode packet data as JSON. I mean, it doesn't really matter that much because it's only the commitment that's stored, not the data. So using an inefficient data encoding format just comes with some slight compute penalty. And maybe that's worth the legibility, which is nice. So it really
but whatever the handler is being handed an arbitrary length byte array, and then it's up to the dynamic IBC implementation as to how it delivers that to the dynamic code in a way that preserves that flexibility.
That's right. And you can impose structure at any level you want. So if you want some additional outer layer of metadata wrapping some inner data field, which is then opaque to your dynamic IBC handler, you could do that.
Right, but that would be at the cost of interoperability with somebody else who didn't make that choice.
That's right.
Yeah, so what we want is, part of the trick there is actually within our limited subset of JavaScript and the way that we serialize messages from one vat to another, we don't have a nice story for arbitrary binary data. So, we can get it up to the Go level, we can get it to the JavaScript level that sits outside the vat, but then to get it from one vat to another, our serialization there is still based on JSON. And so we have to add something to serialize byte arrays and do something, probably kind of gross with it for now. And then later we're going to find a better serialization format for that and maybe do a proto thing.
Right. I mean, in the long run, it's better to use a compact serialization format because this data is on the wire, it's being stored in the transaction log.
Yeah, of course. Yeah, we want it to be as compact as possible. And it's just, it'll run into the expedience that we took by using the performance to use a JSON-based, like use all the native JavaScript code for doing JSON-based serialization with just some replacers dropped in there to deal with objects and promises and presences and whatnot.
So I will note that another potentially interesting option is to use the version negotiation in Channel Handshake to pick an encoding format. So it would be possible, for example, for the specs of application level protocols like ICS 20 to include both JSON and say Proto 3 encoding specifications for their packets, which are simple. So just be like a 5 or actually 4 field object in JSON or a 4 field structure in Proto. And then a particular bit in the version negotiation handshake could pick.
Right.
And as long as both ends support, both ends supported one of the agreed upon protocols, they would be able to talk to each other.
Yeah.
Is it worth the complexity? I don't know. It's possible.
Right. Yeah. That's a question. Kind of maximizing people's flexibility. If we want dynamic IBC to be, it's there to provide. Let there be as many implementations of this stuff as possible, and let people kind of put off those decisions as much as possible. That the complexity of doing that negotiation. Now there's another thing you have to be aware of the other side, kind of. So yeah, we'll have to play with that. I think we'll get more experience with that in the next week or two.
Right. Cool. Sounds good.
Yeah. Thanks.
Any other topics for this meeting?
What do we think is? I think it potentially is probably worth just starting to discuss a little bit of how we're going to manage protocols other than ICS 20, sort of in repos, in as specs, in commits to the IBC code base, etc. What are this is a good question for the microtech people that are sort of on this call. How are you guys? Have you guys given any thought to how kind of a microtick sort of price oracle packet gets defined, and where it could live and stuff like that?
There's a couple issues there. Number one is, how is the data going to be delivered? And ideally, we would like to see two types of data delivery. Number one being streaming data, so that we could propagate through maybe multiple channels via a single event or packet. That would be data that's not actually confirmed. And then there would be a second type of data packet where the request would come across the IBC channel, maybe with some value attached, creating a transaction on the chain that actually results in a authenticated data value that then the DApp could use to, with reasonable assurance that the data is accurate. At least that's kind of the way we're thinking right now. Obviously, there's probably multiple ways we could approach it, but just realizing that there's two different types of data delivery, at least two, there's probably others as well. But that's kind of the way we're thinking right now.
Is it beneficial for your use case to standardize the packet format so that other people running other chains which support IBC can process or produce your packets?
Produce them or process? I think processing them, being able to receive the data is very important. And if we can standardize that so it would work with any type of Oracle, obviously we don't want to customize it such that it's specific just to our particular implementation. If we can abstract it so that we can have a data format that becomes useful to anybody that wants to implement the Oracle pattern on a Cosmos zone. That could be useful.
Right. I mean, a pretty close direct analogy is to Ethereum contract call data standards, which I think are called ERCs, and to go through the EIP process. So when people want to agree on how to call transfer or how to call deposit on a staking contract or how to call lend on an insurance contract or whatever, they write an ERC standard proposal, which includes the function signatures, which get translated into call data encodings, and includes the semantics for how that data ought to be processed in a correct implementation, how it ought to be interpreted.
Yeah.
And basically ICS application standards or IBC application standards need to do the same thing, except that they're not specific to a particular blockchain or contract language or anything.
That would be very helpful, because then at least we could get together and agree at a, just on the standard, and then everybody's implementation could be slightly, different or whatever, but at least they can agree on the protocol and the formats and how to interchange the data.
So it seems to me to be very plausible to have single event to multiple channels be supported over unordered channels only, though I suspect there's probably some work that needs to be done on this, just kind of in the spec. And like there might be some gotchas here.
Sorry, you want one-to-end broadcast on Ether?
So if you think about applications like MikroTik, or like any sort of streaming data application over IBC, it would be, in my mind, well, it seems like, and this is potentially a good thing for us to discuss here. It's like been this like kind of sort of subtext that has been floating around the IBC spec for a really long time, which is like for things like where like you want a single event, and instead of having to construct on chain multiple channels for multiple packets for all the channels that you want, there's actually one-to-end broadcast where essentially you do an initial handshake with a bunch of chains, and then after that initial handshake, data streams from like single on-chain events. So like you kind of have what like Band Protocol wants and what I believe probably MikroTik wants, which is like, every time, in like an end blocker or something like that, you construct packets and they just flow out.
And part of that is that the data could be cached at the relayer level. So, I mean, when you think about it, a transaction would have to happen on the target chain that would affect a state change. And that transaction might be able to query out to the local relayer endpoint to get the most recent cached data. They don't need to receive every single stream data input. That probably makes not a lot of sense. But being able to cache...
So that behavior is handled by unordered channels.
Oh, okay.
What is probably sort of necessary is on the receiving channel, it needs to know. So if you kind of think about the way like packets normally work, they specify the recipient chain, and then the recipient chain like observes that the packet is for them and then processes it correctly. In the like one of n case, it's like essentially a packet where the recipient chain is all, and then and you need a channel that's configured to say, okay, like I will accept all as a specifier and process this because I know how.
Well, I mean, an analogy would be the multicast functionality in TCP. You might want to have a subscriber functionality where a channel could, or a zone could subscribe to data. And then the relayer is smart enough to know that, oh, this zone is not subscribing, so I don't need to forward to any relayers that are making that hop.
Right. So all of this to me sounds possible, but there are several different points in the design space here, and I'm trying to figure out which one you are talking about. So one of the points is where you have a one-to-N broadcast that is literally like UDP multicast, where you don't know who the receivers are and you don't care. But another option is where you have one-to-N broadcasts where N is known and you know the identities of the receivers and only they can receive the packets and only, say, process them once. Do you want the former or the latter or something in between?
So I think ideally, I mean, we'd like to not have to manage all the independent subscriptions because it really makes no difference to the sending side of it. However, that should be managed kind of in the form of a subscriber where if you indicate an interest, you can send out some sort of a subscribe packet coming from the receiver to the network layer, and then the network layer is smart enough to sort out the routing so that when the broadcast happens, it's not going to generate a bunch of useless data that floods the network. It just goes to interested parties and doesn't duplicate traffic.
So the key difference...
hold on, can I just jump
Yeah.
in there before you respond, Chris? From my point of view, I have seen the strongest use cases for the former, for something that is like UDP multicast, and less use case for something that is like the latter, which is like kind of like some sort of like fan out packet, because and you know that's sort of where I'm at right now.
Mm-hmm. The difference between them in terms of protocol is that one-to-N, where N is known, requires handshakes, but UDP multicast does not. You should be able to just create a basically multicast channel, and then receivers completely independently can subscribe to receive it. And when they subscribe to receive it, they're not sending anything to the chain on which the multicast channel is broadcasting from. They're just marking their intent to receive from it, and then relayers can notice they intend to receive from it and actually start relaying the packets. So I mean, it's really one way. There's no negotiation.
That does work. Now, the thing to keep in mind there is sometimes you may be interested in having data that, number one, your subscription model might involve the concept of micropayments, where you can eliminate a lot of spam traffic, and you can incentivize data providers to actually want to provide their data to other chains, just as a general concept. And that wouldn't work unless you had some sort of a subscription mechanism or some sort of propagation of who's interested and who's going to pay for it.
Right. So in the second, if you implement receiver known broadcast, where it's one N and you know the N and the N have to negotiate, then you can gate who can receive. So you can require that they subscribe or something.
If you know the receivers, you can also do things like have stronger methods of data authentication implemented as well. Although you could do that just by being the signer and just sending it one to many, and if everybody knows how to authenticate that, that would work as well.
Right. I mean, to be clear, these things are not mutually exclusive. The IBC protocol can support both.
True.
I was just wondering which you were thinking of immediately, but.
Well, I mean, and that's kind of up to the community. We have certain things. I mean, the streaming data that we're going to be generating is potentially block by block, which is very frequent. So that may be overkill for some applications. So it kind of depends on what the community wants.
Right. I mean, so this will require alterations to the core protocol. This is something we talked about, I recall, with the Goric last summer, but decided not to do it that time because we didn't seem to need it. What is your timeline like? Like, is this months, 6 months, a year?
It depends on what the use cases demand. I mean, we can operate, and we intend to operate whether or not we have the capability of delivering data. So, we're not going to drive the timeline.
I guess, so my point of view on the timeline for this is, in a world where there is a small number of zones that wish to consume this data, the efficiency benefits of a multicast are not so large that, like, let's say there's, we launch MikroTik and MikroTik has 5 5 subscriber zones, like something on that order, single, you know, less than 10. Essentially having a thing where there's like where there are a series of unordered channels that like can be initiated between any 2 chains, and those unordered channels, like MikroTik just says, okay, so like instead of, you know, we'll make 5 packets or 10 packets on every end block. That doesn't, to me, seem prohibitive from an efficiency point of view. I think the downsides of that world are basically that someone has to initiate one of these things. There is some cost to the MikroTik chain, and eventually, like, you would want like a UDP multicast like functionality that would simplify this dramatically, where MikroTik doesn't need to publish an update to every channel in this process.
Yeah. No, I mean that's totally true, and there's a third use case here that we haven't talked about. MikroTik is particularly has the capability of being able to hedge a data value. So not only are you going to be able to receive an oracle value, but if you have a risk in a certain direction, if that data is wrong, we have the ability to be able to hedge that data point. And that's probably unique to our oracle. But something like that, if we had the knowledge of who we were sending data to, and then a transaction comes back and they're somehow indicating that they're using a data point on chain and they want to hedge that, that's a use case that might be particularly valuable to dApps that are in the DeFi space, for example.
I see. One note is that even if you use a UDP multicast channel, it is still possible for a receiver to prove that you sent a packet. You just don't pre-authenticate the receivers, but they can still prove that you sent some data or something like that, if that's what you're talking about.
You meaning chain or the zone?
You meaning, yeah, the price oracle, right? The price oracle is still producing things as a zone, which are in effect signed messages. So those can be, you know, proved to have been signed by the price oracle at a later date, regardless of which broadcast strategy is used.
Okay, so maybe these 2 use cases are distinct. I mean, we just enable a new transaction type that would allow them to hedge, but it doesn't need to be part of the broadcast.
Yeah, it could be. It's easy for IBC already has the data to like check whether a particular packet was sent. It's already kept in the store, so that's easy.
Can we customize with our own API sitting on top of IBC? Like if we have a particular transaction type that we want to enable?
Yes, you can. The interface in the SDK implementation is not written with that in mind necessarily, but it isn't hard to modify it.
Okay. We're not there right now, but these are things that we're definitely keeping an eye on.
Mm-hmm. So it sounds to me like this is, you know, medium-term priority. Probably not worth trying to get into the implementation at this point, the 1.0 implementation, but probably worth brainstorming on the spec side and writing up on the spec side relatively soon.
Yeah, we can keep it open for discussion. There's no blockers. I mean, we're full steam ahead right now. So
okay. It could be, you know, a 1.1 IBC, for example.
Yeah.
Cool. I took notes on this discussion in a new issue on the ICS repository.
Great. Yeah. So my point of view had been on this has been, and it sounds like Mark agrees with me, that it's an awkwardness to MikroTik's protocol that is introduced by having like subscribers have to like initiate a subscription so that MikroTik directionally publishes data that is available and that they don't need in any way actually customized for them to to work, but it's probably unlikely to actually be like a practical problem. It's just like an awkwardness. In the protocol, and it's probably not worth the additional complexity of in anything to try and on the protocol level to like try and remove that awkwardness like ASAP on the protocol layer. But like it should be sort of like for like whatever the 1.1 spec of IBC is, I think UDP multicast like form seems to like naturally like fit in some way.
Yeah. So I agree with that, with the qualifier that I want to make sure that we could write an IBC 1.1 in a way that would preserve the ability to talk to IBC 1.0 with channel types that IBC 1.0 supports. So we want to make sure that we can add this one-to-end broadcast in a way that doesn't break, regular paired, ordered, or unordered channels. So there can occur some kind of version negotiation between the two chains, which already exists at the connection level, just to say, oh, do you support broadcast channels? Yes, no. And if you don't, then I can't create a broadcast channel, but I can still create an ordered channel. And in principle, that should not be hard. It just means that we need to ensure that the way we're serializing things and naming enums doesn't make it awkward. I noted that too.
It is plausible to me, this is Dean, certainly. It is plausible to me that a relayer could convert from what, unordered or ordered channels to a broadcast channel, or a broadcast channel to some ordered or unordered channel on a chain that doesn't understand broadcast with some impedance mismatch, but it should work pretty well.
I don't follow. Even in the case of a broadcast channel, the receiver is authenticating what the sending channel sent, not what the relay is doing.
You're right. Yes, it is conceivable that that format could look like a single cast. A single channel that was just to you, and everyone interprets it as just to you, and so it looks broadcast when sent, but single when received. But you're right.
I don't like that, honestly. I think that's a mistake.
Right. Okay.
I understand, but if we do it that way, it's going to be super confusing. And then we're putting the onus on the relayer to deal with protocol semantics in a way which is just not at all true at the moment.
Yep, I get it. Makes sense.
Hey, Jack, what's up?
Hey, sorry I'm late. Because of the time zone shift, I think my relayer call has ended up at the same time as this call. So I split the group here, and I'm sorry about that.
No worries. We were just talking about updates on Game of Zones development status and discussing one-to-end broadcast for microtext use case.
In block?
Yeah, the question is like in current IBC, there will need to be a unique unordered channel for every receiver in that end block. And so there'll be like some process of being like, I need to register, and then the end blocker has to be aware that like I need to update this many channels during end block. Now, ultimately that shouldn't be that expensive, but it's just sort of like, I know it's sort of like an awkwardness that feels unnecessary. And so we're just talking about that. What is probably like IBC 1.1 candidate.
Yeah, I like that. I think the band protocol folks did push a PR that got relaying packets that were created by in-block working, so that totally works.
Oh yeah, that should already work fine. It doesn't matter when the packets are created.
Speaking of packet creation in unordered channels, that seems to be something that I should prioritize for the relayer.
Well, it sort of depends a little. Well, maybe going through like relayer priorities would actually be a good use of the last few minutes here.
There are a couple of things that I would like to bring up and discuss on that front.
Sure.
Yeah, let's do it.
I think number one is different address prefixes. We've talked about a number of ways of fixing this, but it's still broken. We're going to need that for Game of Zones. So, figuring out a way to lock the SDK config so that we can reset the prefix while we're doing marshalling and unmarshalling. I know this works in the relayer, even for packets with multiple different prefixes on it. So we'll need to figure out how to do that. Actually, maybe with the recent changes to IBC 20. Anyway, that's something that needs some investigation. Unordered packets and channels. Yeah,
can I come back? Can we dial in on that a little bit?
Yes, and let me just talk about the three. Because I think there's three big things. Okay. So that unordered packets and channels, and the additional query functionality, which I have not been able to push forward on this week because of the breaking changes that I've needed to integrate. So those three things are the relayer priorities right now.
Okay, so I think the question that has been to my mind is fixing the prefixes the first thing we should do or the last thing we should do? Like make everything else work and then figure out the prefixes stuff. Now,
this has been the strategy so far.
That it's the last thing we do?
Yeah.
Yeah. So, that dive that we took on it a few days ago, we found that, like, why is there this source address here at all in ICS 20, which was kind of a good find. So the downsides of making it the last thing is we might find other stuff like that if we if we front load it. But it's overwhelmingly likely, I think, at this point that it's just kind of like it's essentially like fighting mutexes, and like you kind of like fight your mutexes until, though I think with that, like I suspect that the situation where like you're in a single context and you need to deal with the SDK outputting both address prefixes should go away now.
Sorry, can you explicate on the point about source address? Source addresses need to process token refunds.
Oh, interesting.
Yeah, but Zachy, I think you're right. It's just at one point, and I think we should be able to take care of it because we do it on the relayer.
So the main point was that for the relayer constructing, oh, is that what it's for?
You can't get rid of it. Well, the only way you could get rid of it is if you keep a map in the sending chain of the packets you sent to the source address, but I'm not a huge fan of that.
Oh, that is okay. I understand now why it's there.
Anyway, yeah, I think that this is something that we should probably start to look into. It would be nice if I could get some help with this one.
Yeah, where is this issue?
Yeah, Chris, so if you set up,
I know what you're talking about. I'm wondering, I thought there was a GitHub issue and I looked at 3 repositories and I've so far failed to find it.
It's in the relayer repo. I wrote it up in the relayer repo, I believe.
Okay, the occlusion one.
I think so. And Zachy transferred over all those issues, so it should be
different account prefix change here. Okay, I found it.
Yeah. And, I put up a PR on the SDK that exposed the mutex and removed the seal from the SDK config. I think that should work. Like, that should totally work.
Well, okay. As far as I can tell, if we're going to handle this, then we actually, so the consequence of not having this map, as far as I can tell, is that prefix information actually needs to be now embedded locally in the address and not in the global config. I don't see any way around this and to support ICS 20.
Okay. Well, in that case, Zeki, somebody definitely needs to deep dive on this.
Chris, do you disagree with me?
I can think of two other options, and maybe they're bad, but the two other options I can think of are, one, that the prefix information becomes metadata associated with well, either a client connection or channel, but for now, say a channel that is decided upon in the handshake in ICS 20 and then is stored. And that's pretty easy to deal with because then it becomes associated like with a particular channel and it should be constant for a given channel. And the other thing is that you put the prefix itself in the packet, but it seems better to associate it with the channel. Presumably that would work.
What if we made a type that was like foreign address? And you could, and the foreign address types could get this would like know essentially what channel they came from. No.
And that's the foreign type mixed with what Chris is proposing would be a solution to this.
That will, I mean, that's just the same thing as embedding the prefix in the address, right? Like we're just naming
it is, but it's instead of doing it for everything, do it for like make a new type and just.
Oh, I see. Sure.
Special type that has.
Couldn't we figure out the prefix by splitting the address at 1? Because the digits of it always start with 1, right?
Well, any Batch32 library is going to split the HRP from the data and give you back both.
Okay. Yeah, so that's not hard.
No, what's complicated about this is what is the internal data type of that, like that it's represented. So I guess there are like kind of these two kind of annoyances, I would say, in this. One is the SDK. So there's two annoyances this. One is the manifestation of the ICS 20 packets source foreign address in the logic of like the on-chain logic, which is where metadata around that, like this is a new address prefix and this exists somewhere else, has to be retained. And I would imagine that for protocols like cross-chain staking and stuff like that, we're also going to need some notion of like addresses that did not originate here. And the second piece is going to be the second piece is that you have on the relayer needs to have some, like as an SDK consumer needs a type that basically allows it to kind of say the type of this is not is an address. I'm very much leaning towards the foreign address with the HRP, the prefix embedded in the address type. But I'm not an SDK developer primarily, so.
That seems good, Zaki.
It feels very right to me, and it feels like it has utility not just for the relayer use case, but like on-chain itself.
Agreed. Chris, what are your thoughts on that?
It is slightly extra data, because the prefix will be fixed for a given channel, but I don't think it matters that much.
Is this something that you would have some time to dig into?
I can try. I know not that much about the way the current prefix mutex thing works, but
Well, okay, so here
It
is
doesn't.
well, the mutex is bad. What I imagine is like literally there's two choices in this. There's like a fork in the road on the abstraction. The fork in the road in the abstraction is you have foreign address type or IBC address type, and if it's IBC address type, every IBC address type has an IBC channel that it points to as like its reference, and the information about how it should be like serialized and deserialized and everything, like the HRP context of that space is defined in the is defined in the channel metadata itself.
that's right.
The alternative is like just have an HRP embedded in foreign address types, which are basically like, it's a class. It looks a lot like SDK address, but it has this additional string in every instance that is sort of static to it, that basically has this. The trade-off that I immediately see is that if a developer wants to create a use case for an IBC address, like for the only use cases for the IBC addresses are like, there must pre-exist a channel before you can create one. There might be some utility in some protocols to be able to like define foreign addresses in the protocol and only have IBC and only have a channel be created afterwards, which would benefit from the like sort of native foreign address component. There's
Right.
You would need, if you had this like native foreign address component, there would probably need to be some sort of checking that like the channels themselves would probably also need some notion of their address space, because you probably want to have a check that says like these things match when they interact with each other. Probably this is a good question to get Bez involved in and see what he thinks. But
I'll talk to Bez about it.
yeah, but I don't like, now that you've said this thing about the source addresses and how you want them to work, and I don't disagree with you, I think mutexing and any of this stuff is actually just like completely the wrong way to deal with this. And I think there's some sort of new type that needs to be created. And that will probably become the dominant address type in the relayer, and then it'll be the kind of like IBC friendly address type for SDK. Are you taking notes, Chris?
Yeah.
Cool. That was a very productive discussion.
I thought that was a great discussion as well. Absolutely agree.
I agree. I think SDK.foreign address is probably worth the slight data cost. It's much more economic. We can check it on the channel.
Anyway, just wanted to surface that. I woke up in the middle of the night thinking about that.
Yeah. All right. Well, if it's giving you nightmares, Jack, I will definitely.
Well, it's not giving me nightmares. You know, it's just like,
I have woken up in the middle of the night thinking about this too.
yeah, it's just random stuff. It's like, it's one of those loose ends that like, I know we can solve. It's not a huge deal, but like we need to solve it.
I
And,
remember sitting in the Berkeley
in the
office
back of
when we
my
made the
head
decision
somewhere.
to do this, and knowing this would be like we would have to deal with this someday.
Yeah, it's awful.
And-
Anyway, yeah, totally agree with you, Zachary. Anyway, yeah, it's just like all of the stuff bangs around in my head. So that, and then, yeah, as far as query functionality, I'm going to focus on having the path creation commands reuse existing primitives to the widest extent possible. So, yeah, that's like just some feature build out I need to do on the relayer.
Cool.
Yeah.
Yeah, I mean, as I start thinking about things like cross-chain staking, I just imagine that having a foreign address type in the SDK is going to end up being like a pretty commonly used primitive.
I definitely agree with that. Might be helpful if the foreign address types supported different kinds of crypto as well.
That idea was sort of bopping around in my head. Except the problem is that unfortunately Besh32 is not sufficiently universal to like support all possible things as a concept itself.
So
like what the universal address, like what a universal address is basically just a string with no I don't know how to abstract this. This is
right. That's what I was thinking. The sending chain doesn't actually care what the receiving address is formatted as. All it cares about are the semantics of, refunding.
How to serialize it and show it to user. Well, yeah, and there's a user level ergonomics around this, which is
one option to get through all of this is to change the type to string. That way we don't serialize and deserialize, and then we leave it up to the application protocol to deal with this.
Yeah, why don't we do that?
I have not been following the technical issue, so I hope you don't need my opinion on that.
No, Dean, we don't. That's actually a way more simple solution that would save us a ton of time. What do you think about that, Zachy?
I'm wondering if you need a new type. It's like a new typed string, but it's like
sure.
And because you probably need some convenience functions around it.
We could use the existing SDK address functions and a mutex in the SDK config to handle all cases on that seamlessly.
No, I don't. I strongly disagree with all of that, what you just said. Like the whole point of this is to actually just like make the mutex not matter.
I'm saying there's a way to get around it.
Okay, you want to talk about this offline? We have a meeting later today. We can talk about this.
Yeah, we do. It might take me 2 seconds to explain this because I think Chris understands it. And if you get it too, then maybe this is a better way forward. So if right now in the ICS 20 struct that unmarshals the packet data, the type is SDK.account address. And this is what we're running into. If we change that type to string, then when we unmarshal, we're just unmarshaling into a string. And then we can deal with each of the addresses individually, and we don't have to worry about refactoring the config or adding a foreign address type or any of this stuff. Now, will a foreign address type be good? Are there use cases in which we need to deal with other crypto besides Batch32 as foreign addresses? Yes, absolutely. Should we put more design thinking into that? Yes, I think we should, as opposed to just like squeezing something in a sprint in the 2 weeks before Game of Zones. Like fixing the code that we have seems like kind of a low lift if we just change that type to string. Anyway, that's just the thought. Does that make sense?
I'm mostly fine if these things are just strings.
Yeah, great, cool.
Is there a reason we didn't do this? I think I even wrote the spec like this and then apparently forgot.
No, there's no reason.
No, I mean, like stringly types of data is always code smell, and like like saying yes to this is causing me anxiety. But
yeah, it's a string in the spec. It does. I mean, it's already the serialization is already chain specific. So
yeah.
Okay, so that might be a lower
for other
lift.
reasons. You want this
Yeah.
for other reasons because then you don't need to synchronize upgrades to your address formats, which otherwise would be a pain in the ass. So
Yeah. Okay.
All right. That might be an easier way to get through this.
Let's just stringly type all of this and like
Really
translate
glad we talked about
everything
that.
with all strings. Yeah.
That's great. Yeah, and then that mutex PR that I wrote for the config will totally work in this case.
right. Okay. Sorry, I have to go to another call.
Yeah, no, it's
great
that time.
discussion.
Thank you guys. Sorry I was late.
No worries.
Thanks, everybody.
See you guys
Good
soon.
call.
See you later.